Alright, here we are. We're on section 8.5, section 2. We're going to focus on graphing tangent and cotangent today. When we are completing the table to find the points of the graph, right, of our tangent, we always want to go ahead and refer to our unit circle. Again, these are just the four corners, just so we're referencing these guys. For my first point, my first theta, right, we're talking about the tangent of a negative pi. Negative pi is just pi. So we're going to take the y over x. It's going to be 0 divided by negative 1. It's going to give me 0, right? Negative 3 pi over 4, it's going to be in quadrant 3. So I'm going to have positive 1. Negative pi over 2, that's just 3 pi over 2. So it's going to be negative 1 divided by 0, give me undefined. Negative pi over 4 is in quadrant 4, so it's going to be negative 1. Tangent of 0 is just going to be at 2 pi, so it's just 0 divided by 1, which is 0. And then the tangent for pi over 4 we know is 1. And we just go ahead and continue on. And we also see that there's this pattern. Okay. So I'm going to go ahead and plot these thetas as my x's. So we have the negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4, 0, and so forth. Go and fill this out. And let's just say there's just 1 and negative 1 on my graph. Okay, then I can start going ahead and plotting the points. So at negative pi, we're going to be at 0. So there's my first point right there. Negative 3 pi over 4 is at 1. We have a negative pi over 2 is undefined. So this is where we have our asymptote. There goes that guy. And then just continue on with this graph. Alright, we got our graph. I'm going to go ahead and connect the dots. And this is what the tangent graph looks like. It's kind of like a snake. Okay, if I'm focusing on one particular part, we're going to focus on this section right here. So then if I'm looking at this, the period length, there is no amplitude, right? Because we're going down to negative infinity to infinity. So there's actually no amplitude when we're looking at tangent. The period length in this case, if we're going from negative pi over 2 to positive pi over 2, right, this is going to be pi. So actually, when I'm trying to find my period length, my equation changes, and it's just going to be p is equal to pi over b. Okay, instead of the 2 pi over b, because the period length is pi, when we're finding the period length given b, it's just going to be pi over b. Okay, the domain is, again, it's all reals, except when we have pi over 2 plus pi times k for some k in the set of integers. Our range, like I said before, is negative infinity to infinity. X-intercepts is going to be pi times k comma 0 for where k is in the set of integers. The y-intercept, we do have 1 at 0 comma 0. And then we have the vertical asymptotes. This is when we have x is equal to a pi over 2 plus pi times k for some k in the set of integers. Okay. All right. So if I'm looking at this one specific area, right, we notice that we are starting at 0 comma 0. So we are going to go ahead and start this point for our parent function. And then you will need to add and then subtract the units twice to get the given asymptotes for tangent. So like what that means is if I'm graphing number 1, we have y is equal to tangent of 2x. Here we do have a b, so our b is 2, so I have to go ahead and find a new period. Again, since it's period length of just pi, we're going to have pi all over the b. And then to find our units, we're going to have pi over 2 divided by 4, and that's going to be a pi over 8. So again, we are starting at 0, 0. I have pi over 8 on both sides. And then, like how it says, you'll need to add and subtract the units twice to get the asymptotes for the tangent. I'm just going to go ahead and add another pi over 8. Pi over 8 plus pi over 8 gives me 2 pi over 8, so that's pi over 4. And then similarly negative pi over 4. And here are our asymptotes. Okay. Alright, I'm just going to put 1 and negative 1 on my graph. And here is my graph of tangent. Okay, number 2. It looks like we have a translation where we're going to go write pi over 4. Okay, so if I'm looking at my parent function, we're going to start with the points of negative pi over 2, pi over 4, 0, pi over 4, pi over 2. So here I'm going to start off with the negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. And I'm going to go ahead and add pi over 4 to all of these units. So I have a negative pi over 2 plus pi over 4. I have to find common denominators. Is that negative pi over 4? 0, pi over 4. That gives me a pi over 2, and then a 3 pi over 4. Okay, so here we're looking at these new units. Again, I just put 1 and negative 1 on my graph. Here's my asymptote. Okay, here's my first point. And there is my graph of this tangent. Alright, so that's tangent. Very similarly with cotangent, same exact thing. I'm going to go ahead and find these values. Cotangent is just the reciprocal of tangent. So that means that all these points in our chart just goes ahead and flips. Right, so this time it's going to be undefined at negative pi, 1, 0, negative 1, undefined, 1, 0, negative 1, undefined, and you see that pattern. Okay, so I'm going to go ahead and fill out my graph. So at negative pi we're undefined, so there's my asymptote. Negative 3 pi over 4, we are at 1, we're then at 0, then at negative 1, then undefined. Go ahead and fill out the rest of the points. Alright, and here are my graphs for cotangent. Again, it's very similar to tangent, but now it's just the reciprocal, so everything is reversed. Right, so if this was my graph for tangent, right, it's going to be the reverse of that. So same exact thing, has no amplitude. The period length is also going to be pi, so that means when we're looking at period, it's just going to be pi all over the b. In this case scenario, we're focusing on this interval or a period of pi. Domain, very similar, all reals except when we have pi times k for some k instead of integers. range -infinity to infinity. The x-intercepts is going to be pi over 2 plus pi times some number of k, where k is in the set of integers. Y-intercept, there is none. And then the vertical asymptotes, when we have x is equal to pi times k, there's some k in the set of integers. Okay, so if I'm looking at these examples, here's my first one. It says y is equal to cotangent pi times x, sorry. So here we do have a b value of pi. Again, we have to go and find the period length. It's going to be pi over pi. This period length is going to be 1. And then this time your units is going to be 1/4. Okay, so it's not like tangent where we have to start at 0, 0. We can go ahead and continue on with our pattern just like with the other ones. Just tangent has that special case. Right there are my asymptotes. Here's 1, -1. So then this is what my graph looks like. Okay. Number 2, we have y is equal to cotangent of 2x minus pi. Again, we have to get this x by itself, so we do have to go and factor some. So I have y is equal to cotangent. I'm going to factor out a 2. The x is now alone. And then this guy becomes a pi over 2. So really, we're going to go ahead and go right pi over 2. It's telling me that my b is equal to 2, so then my period does change. Again, it's the same pattern. It's going to be pi over 2. Then my units is going to be pi over 2 divided by 4, which gives me a pi over 8. Okay, so I'm going to go ahead and write the units down here. I have 0, pi over 8, pi over 4, 3 pi over 8, and then we have a pi over 2. We're going to add pi over 2 to everything. So then it will change the x-axis because of this shift. First one, easy peasy, pi over 2 plus 0, that's just pi over 2. Again, you will have to go ahead and create common denominators. So this becomes 5 pi over 8, becomes 3 pi over 4, 7 pi over 8, and then this becomes pi. Okay, so we're going to go and start at pi over 2, then go to 5 pi over 8, 3 pi over 4, 7 pi over 8, and then we're at pi. Okay, here are my asymptotes. Again, I'm going to go up to 1 and -1, so then here are my points. Oops, and there's my graph for this equation. We are done.